Last weekend, protons and heavy ions were injected for the first time into the LHC machine in two of its sectors, from point 2, where the Alice detector is located, till point 3, and in the opposite direction, from point 8 through the LHCb detector until point 7, where the beam was stopped. Today, an important milestone in the voyage of the LHC towards first collisions is going to be reached with the injection from point 7 to point 6, and if we're lucky, we will continue till point 5. It's worth reminding that the LHC machine is composed of 8 sectors of 3.5 kilometers each, and each of them can be tested and operated individually with the thousands of circuits that they contain. Let's now go inside the control center to speak with one of the engineers in charge and see where they are with this injection of today.
Hi, how are you?
How is it going today?
Well, fine. We are trying to commission the main circuits in sector 6-7 to be able to inject the beam from point 8, making it circulating up to point 7, up to point 6, and then to point 5.
And where are we with this operation?
Well, we are trying to now to ramp up the dipoles to injection current. We have some small issues, but we are quite confident we can do it by this evening.
So what's missing now? Which are the sectors that are still to be commissioned for you to inject everywhere in the 27 kilometers?
Well, let's say that at the moment half of the machine is fully commissioned, and the other half we're on a good way for having the circulating beam. The latest sectors to come are sector 3-4, of course, the one where we had the incident last 19th of September, and sector 6-7 we are nevertheless well progressing today. So we hope by the 21st of November to be ready with all the machine for the circulating beam.
Okay, I'll just let you work now because it's very delicate. Thank you, Mirko.
Thank you.
See you in a few weeks' time.
Yeah, okay.
The tests that are being performed right now require a lot of time, but most of all, a lot of attention, because the LHC is an extremely complex machine.
This machine is extreme in many respects. Extreme for its intrinsic difficulty, 27 kilometers of superfluid helium, very high beam power, very high energy density, very little, zero margin for errors. So this is a very, very difficult machine. So
8, okay. Yes, you've closed already 4, 5, and 5, 6 islands.
And Saturday evening, November 7th, the CCC engineers managed to get a beam of protons until point 5 through the CMS detector. For the first time, CMS could see tracks of particles instead of just cosmic rays.
This is the first time we would get accelerated particles going through the experiment. And what happens actually is that a beam of protons, 5 billion protons, strike a collimator. These are protons which have 450 GeV injection energy, and they lead to lots of other particles, mostly muons. And so there's a wave of particles, a tsunami of particles, which goes through the experiment as a single wave. And we had about 1,000 of these waves. And this data also allows us to actually check the timing of the detectors, because it's a single wave which goes through the detector, so it's also quite useful, and it checks that the detectors are functioning well. And so there was, again, great excitement when the first shot comes through and all of the detectors fire, and so in the control room everybody's shouting, "We've seen the wave, we've seen the wave."
Next step is going to be injection into the entire 27-kilometer circuit of the LHC. Keep following the LHC news.